In the tiki 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 room, in the tiki 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 room, all the birds sing work and the flowers grow. In the tiki tiki tiki.
Software projects produce large quantities of data, including requirements, design artifacts, source code, project plans, bug reports, and so on. If leveraged effectively, this project data can provide significant intelligence to project stakeholders. For example, a stakeholder could ask,
What is the history of changes for this component?
or,
Who are the experts on the interface to Hadoop?
unfortunately, project stakeholders often lack the skills they need to formulate queries using languages such as SQL or XQuery. Existing natural language interfaces, such as Jeeves or Siri, return only generic answers to questions. We therefore introduce TiQi. TiQi allows a user to express a query in either spoken or written natural language, and then transforms it into executable SQL statements. TiQi first retrieves the data either from a centralized database or from the natural repositories in which it resides. It displays the available artifacts and attributes, as well as software analytic functions that are available for queries. People can query against the raw data, for example.
Show me all software requirements realized in UML classes.
They can also include analytic functions in their query. For example,
Who is the best person to check the fault-prone classes and components related to temperature controls?
TiQi takes the natural language query and transforms it through a series of steps. Here we see it uses a Stanford parser to remove preludes and other parts of the query. It then creates an ordered list of tokens and maps the tokens onto artifact names, attributes, or actual data values. When ambiguities exist, for example this ambiguity about where arm movements should map, then TiQi applies a series of disambiguations to choose the most likely result, and then from this it generates the SQL query. Now, let's test drive TiQi. We are going to open the Isolate project. The first thing you'll see is the traceability information model showing all of the artifacts available for querying against. This model, including its layout, is dynamically generated using visgraph from data stored in the database. You can click on any artifact to see the raw project data. Each arc in the graph represents a hidden trace matrix. Let's take a look at our first query.
Which hazards are associated with high-severity faults?
When we submit the query, the TiQi engine processes it and returns the results screen. First, the query as TiQi understands it is visualized as a subset of the traceability information model, and it is also visualized in simplified SQL. Finally, data results are displayed in a simple tabular form. Now, let's take a look at a couple more queries.